If I take this car and I crank it 4 times, and then I let it go on this track, it goes into this drum and it spins around the drum. And we're going to count how many times it goes around. Here we go. 1, 2, 3, 4, 5, 6, 7, and 8 times around. Now, suppose I was to take this car and crank it not 4 times, but 8 times. If I let it go down the track, how many times do you think it's going to go around the drum? I'll give you some choices. And in fact, I'm sure what you guessed was this. You guessed if I cranked it twice as many times, it'll go twice as many times around the inside of the drum. So I'm sure you guessed that it's going to go around 16 times. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 times around the inside of the drum. And in fact, it does go 16 times around the inside of the drum. And you know why this is true. When I crank the car like this, I'm putting energy, I'm storing energy in a spring. And when I let it go, that energy is being used to make the car go around. And in fact, it takes a certain amount of energy for the car to go once around the inside of the drum. And if I put twice as much in, I get twice as much out. So this is a great illustration of the principle of conservation of energy. It's something you've heard of before, something you're familiar with. But in Chapter 10, we're going to take this idea of energy and the conservation of energy, we're going to make it more quantitative, and we're going to extend it. And there's 2 important pieces of the puzzle which we need to think about. First off is we need to think about what forms of energy we have. And this toy right here, it's a real simple toy. It's a little spring toy. I pull this down, let it go, it bounces up and down. It uses the 3 most important forms of energy which we're going to consider in this chapter. And the first one is this. If I take this toy and I pull it down, it's got elastic potential energy. There's energy stored in the stretch of the spring. It's elastic because it's stretched, it's potential because it's stored. So elastic potential energy. When I let this go, it turns into kinetic energy. This toy moves. The little octopus goes up. Kinetic energy is the energy of motion, okay? So I have elastic potential energy, kinetic energy as it starts moving, but then at the end, if I let this go, it goes up. Right at the top, it's got another form of potential energy. It's stored, it's gravitational potential energy. So this toy goes from having elastic potential energy to kinetic to gravitational potential, and then back and forth. And so as this goes, every cycle, it's going from elastic potential to kinetic to gravitational potential energy, and then back. If I raise it up, it's got gravitational potential energy. Let it go, it goes into kinetic energy and elastic potential energy when it's stretched here at the bottom. So this toy is all about converting energy among those 3 different forms. And those will be the 3 most important forms of energy we look at. But there's one more that's a crucial piece of the puzzle that's often overlooked. Let's take a look. If I take this ball and I drop it, here's what happens. It's got gravitational potential energy. When I let it go, that gravitational potential energy is transformed to kinetic energy as the ball falls. But when it hits the table, it bounces. And here's what's happening. That kinetic energy is transformed into elastic potential energy. The ball compresses, and then it rebounds. In fact, this happens with any ball that you drop. It deforms. The energy is stored in the form of elastic potential energy. The ball comes to rest, then it rebounds. The elastic potential energy goes back into kinetic energy, and the ball rises up. But how about this ball? This one works differently. This ball, when I take it and I drop it, it doesn't bounce. So where does the kinetic energy go? I've got gravitational potential energy, turns into kinetic energy. When the ball hits the board, the kinetic energy seems to have been lost. But we know it's not lost. It can't go anywhere. Energy can't be created or destroyed. The only possibility is that it's transformed into another form of energy. And what form? We can tell by using the thermal camera. So if we look at the ball with the thermal camera, the ball is cool and my hand is warm. And if I look at the bottom of the ball is cool. Now, I'm going to raise the ball up in the air. It's got gravitational potential energy. As it falls, it turns into kinetic energy. And when it hits the board, let's take a look with the thermal camera. And what we see is the bottom of the ball is warm. So the kinetic energy turned into thermal energy. The bottom of this ball where it hit the board is perceptibly warm. So the energy wasn't lost, it's just in the form of thermal energy in the ball. Now I'm going to take a look at another toy. And I've got this little helicopter toy here. And here's what I'm going to do. I'm going to take the helicopter and I'm going to put it on this holder. And when I pull back on this string here, what's going to happen is the blades are going to start to spin very, very rapidly. And you know what happens next. What happens next is the helicopter is going to rise up and it's going to go out of the frame. And here we go. So let's think about this. I pull the string, the blades start to spin, and the helicopter rises up. Now as it's rising up, the gravitational potential energy of the helicopter is increasing. That energy had to come from somewhere. What form of energy is transformed into the gravitational potential energy of the helicopter? As the gravitational potential energy is increasing, there's another form of energy that's decreasing. And what is the form of energy that's decreasing? We'll give you some choices. And in fact, when I pull the string, the blades spin. That's kinetic energy. There's kinetic energy of the spinning blades. And then, as the helicopter rises up, what happens is this. The blades slow down. And so the gravitational potential energy increases. But as it's increasing, the kinetic energy of the spinning blades is decreasing. So this is a kinetic energy to gravitational potential energy transformation. But we want to look at some more examples of energy transformations, and we want to start to make it quantitative. We want to put some numbers on it. And we'll do that in our next segment.